Alright, great. Without wasting any more time, let's start with the first HackerRank problem. So let me see what the first HackerRank problem is. Alright, so it's called number line jumps. Oh, and look at it, interestingly, it gives you 100 points, guys, straight 100 points. Okay, now let us read the problem. I'll increase it a little bit. Okay, now what he's saying is you are choreographing a circus show, with various animals. For one of the acts, you are given 2 kangaroos. I hope all of you know kangaroo is that animal which jumps, right? On a number line, okay? You are given 2 kangaroos on a number line. They are ready to jump in the positive direction, which means always in the forward direction only they will jump. That is towards positive infinity, okay? The first kangaroo starts at x1 and moves at a rate of v1 meters per jump. That's the speed, or that's the distance it can cover in a jump, right? So it starts at x1 and if it jumps v1 meters it can cover. That's what it's saying. The second kangaroo starts at x2 and can move at the rate of v2 meters per jump also. You have to figure out a way to get both the kangaroos at the same location at the same time as a part of the source. So there is one kangaroo here, there is one kangaroo here, both have to start jumping. Now this will jump at a certain speed, this will jump at a certain speed. You have to make sure that they will jump and both will land at the same place. You have to orchestrate, or you have to ensure that the position of the kangaroos and their jump or the meters per jump is aligned in such a way that they'll jump and land up at the same place. Anyways, example, see, x1 is at 2. The distance or the speed is 1 meter per jump. x2 is at 1 and v2 is 2. Now after one jump, both of them will be at 3. Okay, that is what he's saying. So the answer is yes. After one jump, imagine this fellow is at 2. If he jumps 1 meter, he will be at 3. This fellow is at 1. If he jumps, he will jump 2 meters, which means plus 2. He will reach at 3. This guy also will be at 3. This guy also will be at 3. So both have landed at the same position. And that is what the circus expects you to do. Alright. Now come down. Function description. Complete the function kangaroo. I'll copy that. Kangaroo has the following parameters. So x1 v1, x2 v2. x1 is starting position and jump distance of kangaroo 1, and x2 v2 is for kangaroo 2. What should it return? Either yes or no. When should it return yes? If after jumping they will land at the same position. No if at that given position, at that given jump per meter or meters per jump, they will never land at the same position, you must return no. That's it. And there are few constraints. See, look at this constraints, it's very important. What he is saying is, it is guaranteed that x1 is always going to be greater than or equal to 0 and it is going to be less than x2. Which means x1 is always going to be behind x2, or the starting position of kangaroo 1 is always going to be behind kangaroo 2. That's what it basically means, right? And v1 can be between 1 to 1000, v2 also can be 10,000. Any confusion till here? Beautiful. Let us visualize this code for better understanding. Okay, so let us visualize it. Now listen to me carefully. So this is how it works. Let us take a scenario. Okay, this is the first scenario. In the first scenario, these are the values given to me. Now what are these values? x1 v1, x2 v2, and that is what I am also showing. This is kangaroo 1. Its starting position is x1. Its jump meters per second it can jump, or per jump how many meters it can cover is v1. So that is what I am showing. This is kangaroo 2, x2 v2. Hope I am clear. 0, 3 is x1 v1 value. 4 and 2 is x2 v2 value. Now they are saying it is on a number line, right? So there is a number line. So kangaroo 1 is starting at 0. Kangaroo 2 is starting at 4. Okay, beautiful. So we got their positions. Now what you must see is they are going to jump. This guy can jump 3 meters per jump. So which means if he jumps 1, 2, 3, he will reach here. If this guy jumps, he can jump 2 meters, which means 1, 2, he will reach here. So like this, they will be jumping. Will they land up at the same position at any given point of time towards positive infinity? That is what it means. Let's see. Let's make them jump. Okay. So plus 3 is what he can jump. So if he jumps, he will reach here. Plus 2 is what this guy can jump. Would you agree with me? And if in case he jumps, he is going to reach here. Hope I'm clear. Again, they are going to jump. Again, they are going to jump. And now, tell me, again they will jump. If they jump, beautiful, they have reached at the same point. So this is what they want. If they will reach at the same point, your output must be a yes. I hope everybody understood the question. How many of you understood the question? Put a yes in the chat if the question is clear to everyone. Yes? Okay, nice. Good. Great. Let's move forward. Okay. Now the next thing is like this, right? Let's take another scenario to try and understand, because it's an algorithm or a logic we have to ultimately build. So these are my x1, v1, x2, v2 values. So this is my kangaroo 1, this is my kangaroo 2, and of course these values are inside it. Okay. So if this is the case, this is my number line, and on my number line in the 0th position I have kangaroo 1, and in the 5th position I have my kangaroo 2. Any confusion? Now, this guy is going to jump with at 4 meters per jump. This guy is going to jump 2 meters per jump. So see here, first time they will jump plus 4 plus 2. Next time they will jump. Now obviously this guy will jump plus 4. He will reach here. This guy will jump plus 2, he will reach here, which means next jump he is going to overtake. He is going to overtake. Now he has overtaken, boss. He has overtaken. If he overtakes, if the first kangaroo overtakes the second kangaroo, then will they ever meet? Think about it. Will they ever meet? Because very simple. Look at the speed of the first kangaroo, 4. Look at the speed of the second kangaroo, 2. First kangaroo overtook the second kangaroo. First kangaroo is faster than the second kangaroo. Now if they keep jumping, will they ever meet, or will the first kangaroo always be ahead? If you think they will meet, put yes. If you think they will not meet, put no. And this basically tells me whether you have understood the question or not. No. No. Never. Beautiful. Beautiful. Correct. You guys are right. You are absolutely right. Okay. Which means they will never ever meet. And that is what I am also basically trying to prove to you, that the answer is going to be a no. Okay. Great. Which means let us now take the next scenario. The next scenario looks something like this, wherein these are my x1, v1, x2, v2 values. So this is kangaroo 1, this is kangaroo 2, and these are the values. And of course, this is my number line, and on my number line, the first kangaroo is at the second position, because see, it is always guaranteed that x1 will be less than x2. It is always guaranteed that the first kangaroo will always be behind the second kangaroo. So this is guaranteed to us. Okay. Now here, very simple, we will look at it. See, they will jump. They will jump. Again, he will jump. So tell me, will this guy ever meet? Never ever. He will never ever meet. I hope you're able to think. So obviously, even in this case, the answer must be no. Why? Because look at this. V1 less than V2. If V1 is the speed of the first kangaroo, if that is lesser than the speed of the second kangaroo, would you agree? It's common sense, it's laws of physics which says that if the starting position is behind, if the starting position of the kangaroo 1 is behind kangaroo 2, and if kangaroo 2 speed is not greater than kangaroo 1, will kangaroo 1 ever be able to catch up to it? Never. Which means one of the easiest ways, or one of the conditions which you must check in order to return no or tell they will never meet, is just check if in case the speed of the first kangaroo is lesser than the second kangaroo. If it is lesser, they will never ever meet. It is common sense. How many of you understood this condition? Put a yes in the chat. How many of you understood the condition? Everybody understood. Beautiful. Good. Good. Great. Now let us go ahead and see how to write a logic for this program, and of course answer is going to be no. Okay. So now the logic of the program is very, very simple. So is this okay, fine. Yeah, leave it. Go to the next one. Yeah. I'll just bring up the editor. Now guys, the concept is very, very simple. Okay. So I have day 3 is the name of my class. I have my main method. I will come inside the main method, and there what I'm going to basically be doing now is I will start with the variables that I have. So what they will give me is 4 values: x1, v1, x2, v2. So I will tell int x1 equal to some value I will give. Okay, int v1, we will make it as 1 maybe. Next we will make it as int v2, oh okay, x2, yeah, give some value, 5, okay. Next I will make v1 as v2, some value I will give. Okay, any confusion? Obviously, you know, v1 is less than v2. They should never meet. Technically, they should never meet. But our program should tell us that. We should not do it. Anyways, I'll go on top and I'll create a function called as kangaroo. So I'll call it as static. By now, you know why static. What it has to return is a yes or a no, which is nothing but a series of characters or a string. Name of that function is only kangaroo. And it accepts 4 parameters, 4 integers. So I'll tell int x1, comma int v1. Similarly, int x2, comma int v2. Next I will come inside this. Now, very, very simple guys. Okay. x1 is initial position, x2 is initial position of both kangaroos. Every time they jump, they will reach a new position. So I want to know what is the new position always. So what I will do is I'll create int new x1, like that, new x1. That is the new position of x1. Initially, what will be the initial value? Initial value is whatever is the initial position. So I will tell x1. I think everybody can understand that the new x1, initially what should be the value is whatever is the initial value, so x1. Next I will tell int new x2, and that also initial value has to be x2, wherever x2 initially is. Then when it jumps, we will calculate. So now what I will do is I will press enter. First of all, obviously I have to take new x1, I have to add the meters that it can jump per jump, and that will be my new x1. And then similarly I should calculate new x2, which is nothing but existing value of new x2 plus v2. I will get the new position of x2. Now I must check whether the new position of x1 and the new position of x2, are they the same? If they are the same, it means they have met. If they have met, I should return yes. If they have not met, I should not return no. Instead, I should keep jumping and seeing whether they will meet. Now, till when should I keep making them jump is the question. Very easy, watch it. I will tell, first let's calculate the new value of new x1. So I will tell new x1 equal to old value of new x1. Old value of new x1 plus the meters it will jump, which is v1. Great, semicolon. Similarly, I will tell new x2 is equal to new x2 plus v1, v2, correct, v2. Okay, so I've got this. Now what I should do is, I should always check if in case this new x1 is equal to nu x2, which means they have landed at the same position. Equal to nu x2. Now I'll come inside this here. And if this condition is satisfied, I know they have met, I should stop. So I'll tell return. Return, what to return? Double quotes, yes. The way HackerRank is expecting. Yes, I will tell. Okay. Sir, what about no? What about no is, see, listen, this three operations, calculating nu x1, nu x2, checking if they are equal, this should keep repeating. They should keep jumping. At one point they may meet, they may not meet. Now, how will you find what this? So this has to be put inside a loop. Now this loop should execute as long as a certain condition is satisfied. Now what could be the condition? The condition should tell you that, hey, never these two people will be able to meet. That is what the condition should tell you. So how I will write it? Very simple. According to me, both of them are jumping. They may meet. If they meet, very good. But if they don't meet, how I will keep making them jump is, as long as this first kangaroo is behind the second kangaroo, there is a possibility that in the next jump they may meet. But if the first kangaroo crosses the second kangaroo, then there is a possibility that they will never meet. Because if this person crossed him, he will cross him only and only if his speed is faster. If his speed is faster only, he will cross him. Once he crosses, he is anyways fast, he will continue to always have the lead. I hope you are able to think. So what I will do is, I will cut this entire code. And I will tell if in case, or I will tell a loop I want. Which loop will you use, sir? See, I don't know how many times it should loop, but I know as long as a certain condition is satisfied, it should loop. Tell me, when I don't know how many times it should loop, but I know the condition for looping, should I use for or while? Very good. Because as long as effect is always while. So see, I'll go tell while. What is the condition we will see? I'll leave that empty and inside that I'll just paste it. Now, keep jumping, checking if they are landing. Keep jumping, check if they are landing. Keep doing this as long as what? The new value of x1 is less than or equal to the new value of x2. I hope you are able to think. Any confusion till here? So as long as he is behind or it is equal, or in fact just behind is enough, right? Yeah, less than equal to or less than is also fine. Any confusion till this point of time? As long as he is behind, do it. The moment he comes to the same position, that anyways we would have, this condition would have checked it. Okay, now see, we will do this. Now the thing is, if this never becomes yes, if it comes, if control enters if, you will tell return yes, and what will happen is, return means immediately you will come out of the function. That is how return works. The moment you tell return, you come out of the function. So for me, if return means I would have gone out of the function, but if it did not return, I will come out of the loop. If I come out of the loop, what does it mean? It means that they will never meet. It means that this condition became false. If this condition became false, x1 or the first kangaroo has crossed the second kangaroo, which means it is going to be a no. So see, I will just come out here, mechanically I will return no. Return no. Capital N. Any confusion till this point of time? However, sir, you only told that before doing all this drama, there is an easy way for us to check if they will never meet, which is to check if the speed of the first kangaroo is lesser than the speed of the second kangaroo, then they will never meet, sir, that we have established. Where is that condition? Watch it. I will go here and I will press enter. And there I will tell, hey, listen, don't do all this. First only you check if in case V1 is less than V2. If V1 is less than V2, they will never meet. So directly return no. I will tell. Return no. Any confusion till this point of time? So see, once this function is called, I will pass the initial positions and their speed. First I will check if speed of first kangaroo is lesser than second kangaroo. Directly I will tell no. Otherwise, I'll keep making them jump, find their new position, check if their new positions are equal, that is whether they will meet. I'll keep making them jump as long as the first kangaroo is behind the second kangaroo. The moment the first kangaroo crosses the second kangaroo, then I know that this condition is not satisfied. I will come outside, I will return no. But if at all the new positions were equal, I will return yes. How many of you understood the logic here? Please put a yes if you understood what I said. Good. Good, great. Now let us see, let us test whether it will work. So if I scroll down a little bit, you can notice that here I've told x1, v1, x2, v2, and you can see v1 is less than v2, which means I know they will never meet. So I'll come down and I will just call the function. So I will just tell kangaroo, and I will pass x1, v1, everything I'll pass. I'm just passing these values, sending it as input. Whatever it returns, I can collect it in a variable and then print, or I'll just directly put this within system.out.println. Any confusion till here? Let's go execute it. So, if in case I take you and I compile the program, no issues. If in case I execute the program, no. Yes, they will not meet. Okay. Let's put a condition where they will meet. They will meet. Okay. So very simple. I'll make x1 as 1, or I'll make x1 as 0. Okay. I will make this as 3. I'll make this as 2. I'll make this as 1. Which means the first jump itself, this fellow will reach third position. Right? This fellow will also reach third position. Both of them will reach the same position. You should get yes. Let us go check it out. Okay, no issues. Upon execution, yes. Any confusion till this point of time? So it has worked. Okay, sir. What else? Which means it has worked. Now, I think that pretty much gives you an idea about the way this program works. However, will it work on HackerRank? That is the bigger question. Will we pass all our test cases? Let's go check it out. Scroll on top and I'll just copy this body of the function. Complete body I will copy. Okay. I will go and I will paste it in HackerRank. Okay, so this is Python, please change it to Java. I'll just paste it there. Okay, I'll just click on run code. Then it is telling a wrong answer. See, here the first test case 0342. Obviously, your output is yes, expected output is yes. But as you can see, the only issue is, sir, yes, it's correct, sir. No. That is where many people fail in these competitive programming websites, because the way they are designed is that what their output is expectation, you should print the same thing. Sir, yes. No, it is not the same. Capital Y, small e, small s, capital S. Case sensitive it is. They are expecting capital YES, capital NO, but we have written small. So though logically we are right, what we are returning is wrong. So they will say it is not right. So go on top to HackerRank. All I will do is I'll make that capital No. Every capital Yes, top also capital No. That's great. I'll click on run code. So the same two test cases which previously failed are now passing. I will go and I will click on submit code. And upon doing so, there are n number of test cases. How many? Oh my god. 30 test cases. Okay. 30 test cases they have passed. Congratulations. Okay. Congratulations to you too.